other video, we looked at the law of sines and the law of cosines used to solve oblique triangles. And recall, oblique triangles are triangles that do not have a right angle in them. Now, in that video, I alluded to the case of the side-side angle. So when you're given information is side, side, and angle, then you actually have something called the ambiguous case. And that's the topic of this video. So when you're solving a triangle with the ambiguous case, side, side, angle, remember the convention is going to be that when you set up your triangle, you're going to have the triangle where the angles are marked with capital letters, and the sides opposite the angles are going to be marked with the small case of that matching letter. So across from angle A is small case side length A, across from angle C is side length C, and across from angle B is side length B. Now, in working with this, with our side-side angle case, the ambiguous case, we're going to use the law of sines. And the law of sines is that the side A is to the sine of angle A, as side B is to the sine of angle B, as side C is to the sine of angle C. And I actually just use two of them at a time, depending on which three pieces of information and then which one that I want to know and how I need to pair that up in working with the law of sines. Also, just as a kind of stand back and think about this, it makes sense sort of idea. When you're dealing with the law of sines, it's called that because the sine function is involved in it. And when you're looking at the law of cosines with other types of information for a triangle, then it's the function cosine that's involved with it. Okay, so for our ambiguous case, it's called the ambiguous case because there's a lot of different scenarios that might play out. And part of the difficulty with this is trying to decide which scenario you have. So side-side angle means that you have two sides and then an angle as you're going through there. So if I were to kind of go around this way, I would know side B, I would know side C, and then I would know angle B. But I'd know two sides, skipping the angle that's between them, and then that angle that's on the other end of the rotation around. So this would be like knowing side C, knowing side A, and knowing angle C. Now, if you do side-side angle, like around your triangle, it works out that you're going to have two small case letters for knowing two sides, and one capital letter for knowing an angle. And then also, because of the way it's done with convention of naming it, if we use that convention, the angle name is going to match one of the small case letter side names. So when I look at side, side, angle, see how this small case C and capital C match? If I go side, side, angle, the B's match, etc. So that's kind of how you can identify it when you look at your given information if they've denoted it that way. Now, trying to figure out what the scenario is. When you have two sides and an angle, you've realized it's the ambiguous case, you always want to put one of the sides you don't know horizontally. And then off of that, kind of eyeball the measure of the angle that you do know. So that's going to be your angle that you know. And then make the sides that you know kind of off the angle and then the opposite one. So when you have angle A and side, let's say B and A, then side A would be over here and your side B would be there. So these are the pieces of information you know from the side-side angle. And if you just draw it like this, instead of like doing a lot of different rotations on it, you can start to get a pattern of thought in terms of how to realize which situation you have and be successful in solving that triangle. Now, when I look at knowing that I have the ambiguous case, the first thing I want to determine is whether the angle they give me is an acute angle or whether the angle that they give me is an obtuse angle. Remember, acute angles are between 0 and 90 degrees, and and obtuse angles are between 90 degrees and 180 degrees. So you look at that degree measurement and you say, is that degree measurement between 0 and 90 degrees, or is that degree measurement between 90 degrees and 180? Now, if you've seen that your angle is acute, so I have this diagram, this is the side I don't know, and then the yellow and the red are the sides that I do know. Now, if I hold this opening as an acute angle, it has to be between my 0 and 90 degrees. And I have this side opposite the angle, and then the yellow one is the side adjacent to it. So if I have that the side opposite the angle is shorter, so that's what I have here, than the adjacent side, then I really have three situations that could happen. I could have it where the angle is so small that this shorter side is actually going to hit that side I don't know and make this triangle, but it could also be swung in and make that triangle. So if my side opposite my is shorter than the adjacent side, and while solving it I get an acute angle here, then I actually have two triangles. And the first one I get will be this acute angle, and then the second one I get, I'm going to have to think about taking the straight angle here, subtracting off the angle that I have that would be in that isosceles triangle, and 180 degrees minus that would be the angle here for the second triangle, and then solve that one. Now, if the angle that I have is just right, and this shorter side just touches that other side, then that angle is going to be a right angle, and I'm just going to get one triangle. So if when I solve it I actually get 90 degrees for that angle, then it's just going to be the one triangle that I have. Now, if my acute angle is maybe like this, and so that shorter side isn't long enough to reach down to this other side, then I'm going to get an error in my calculations and I won't have a triangle at all. So that's the case where my angle is acute and my side opposite is shorter than my adjacent side. So what if my angle is acute and my side opposite is longer than the adjacent side? So again, here's my acute angle, here's my side adjacent, here's my opposite side. My yellow one now is the opposite side, my red one's now the adjacent side, and this yellow one's longer than the red one. Well then, I'm just going to get that one triangle. Because if I think about this length has to hit the white one if you could make a second triangle, but if I try to swing and keep that angle there and go, I'm going to totally miss that other side. So I'm only going to get that one triangle. If angle is acute, side opposite is longer than the adjacent side, I'm just going to get the one that comes up. Okay, the next case is, what if your angle is obtuse? So now I'm going to hold my red so that I make an obtuse angle in here, and the side opposite, so my yellow side with how I have this set now, is longer than the adjacent side. So obtuse angle, yellow is longer than red. When I put it down, I'm just going to get one triangle, because again, you can't swing it to get the other one. So you're just going to get one triangle there. Now, if you have it where I go back to my setup where the adjacent side is longer, so angle is obtuse, I have to hold this bigger than a 90-degree opening. Side opposite, this red side, is shorter than the adjacent side, then it doesn't make a triangle. So there's no triangle at all. And again, with these, I can just look at the numbers. And with this one, I can look at the numbers. The one where you really don't know specifically which one you have until you work through the process is when you have an angle that's acute and the side opposite is shorter than the adjacent, to whether you're going to get the two triangles, one triangle, or no triangle. So let's look at some examples of these ambiguous cases. So So here it's to solve the triangle, and it gives me angle A is 41 degrees, side C is 14 feet, and side B is 9.0 feet. So my angle is to the nearest degree, so my lengths of my sides are to two significant figures. If you've forgotten about significant figures, I've linked a video on significant figures in the description of this video. All right, so I have two sides and an angle, and the angle letter matches one of the side letters. So when you have two sides and an angle, and the angle letter and one of the side letters match, that's your ambiguous case. Now, I look at my angle and it's 41 degrees. 41 degrees is an acute angle. It's an angle whose measure is between 0 and 90 degrees. So I'm coming down this branch. And the side opposite that angle matches its letter. So the side opposite is B, and the side adjacent then must be C. So my side opposite is 9, and my side adjacent is 14. So the side opposite is smaller than the side adjacent. So right now I'm angle is acute, side opposite shorter than adjacent. I'm just going to have to work it through to see which case I have. And when I'm looking at this, I'm going to use the law of sines. And with even like the setup of this, I have angle B, and the side opposite angle B is side B, and then I have side C. So B is 9.0, C is 14 feet, and my angle B here is 41 degrees. Just kind of as a setup. Okay, so remember law of sines. I have side B and angle B, so I'm going to use that ratio. So 9.0 is to the sine of 41 degrees, as I have side C, so my first thing I would go after angle C, as C, which is 14, is to the sine of angle C. Now we're going to go through and cross multiply, so 9.0 times the sine of C is equal to 14 times the sine of 41 degrees. And then divide both sides by 9. I have the sine C is equal to 14 times the sine of 41 degrees divided by 9.0. And then to find angle C, I'm going to do the inverse sine of both sides. So we have C is equal to the inverse sine of 14 times the sine of 41 degrees divided by 9.0. But when you do this, when you calculate this through, first of all, make sure you're in degree mode. You want to make sure that you're in the mode that you need for the question. But when you key this through and you're in degree mode, you're going to see error. Because actually this ratio comes out to be a value that's bigger than 1, and there's no angle that has a sine ratio greater than 1. And so you get an error for that. So that means that with this situation, I had my acute angle, I had my length CB 14, my length of side B being 9, and it's too short. It doesn't hit and make a triangle. So that case is no triangle. Okay, let's do the next one. The next one I have angle B is 121.32 degrees. Side B is 8.725 inches. Side A is 2.507 inches. Wants me to solve the triangle. I have two sides and an angle, and the angle name matches the name of one of the sides. So I have my side angle ambiguous case. Next, after I identified that I have a side angle ambiguous case, look at your angle. is your angle acute or is your angle obtuse? So my angle is 121.32 degrees. My angle is obtuse. Now once I look at my angle, if I want to visualize the triangle, remember the horizontal is a side you don't know. Your first thing is the angle you know, and it's obtuse. And that's angle B. And I'll move this off. And then the side B is opposite angle B. So that's this one over here. That's your 8.725. And the other side they give you is the one that's adjacent to B coming off of the angle. So this is your side A, which is the 2.507 in inches. So look at the numbers. The side opposite angle B is 8.725. And the side adjacent to B is 2.507. Well, 8's a bigger number than 2 is. So my side opposite is bigger than my adjacent side. So when I look at it, my side opposite is longer than the adjacent side. I'm going to get one triangle. So I'm going to get a triangle. All right, so let's go through and solve it. So I have here that a pair of information is side B and angle B. So B is to the sine of B. So my 8.725 is to the sine of 121.32 degrees as A 2.507 is to the sine of angle A. So whatever that letter is, that's the angle you're getting. Okay, solve this. Do your cross multiplication. That gives me 8.725 times the sine of A is equal to 2.507 times the sine of 121.32 degrees. Divide by the 8.725. I get that the sine of angle A is 2.507 times the sine of 121.32 degrees divided by my 8.725. But that's what the sine of angle A is. We want angle A, so we're going to do the inverse sine of both sides. And I get A is equal to the inverse sine of that expression. Inverse sine. Okay? So when I go through and work that through, I'm going to get that it's approximately 14.21 degrees. Now, my other angle was to the nearest hundredth, and with the nearest hundredth, your side lengths are to 4 significant figures. So 1, 2, 3, 4, 1, 2, 3, 4. So falling in line with that, we are going to get that our angle A, we need to leave to the nearest hundredth. So 14.21 degrees. Now I know I have that one triangle, and now I have 2 angles. So I can go through and take 180 degrees minus the sum of these 2 angles, and I'll get that angle C is approximately equal to 44.47 degrees. And then I'll apply the law of sines again, where I have C is to the sine of C as B is to the sine of B. And we'll get side C is approximately equal to 7.155 inches.